Okay, because binomial distribution is so important, so today we're going to do some more practices on the binomial distribution, all right? Tomorrow's main topics are to solve real-world problems involving binomial distributions. Okay. First practice. I'll leave you 5 minutes to solve this question, and then we'll discuss the solution, all right? Okay, 2 dice are rolled 5 times. What is the probability that doubles occur twice? All right, have you finished? Because here you roll 5 times, right? Each roll is independent, and the probability of you roll a double is constant, right? Okay, first of all, You need to calculate the probability of rolling a double in each row. Okay, in each row, the probability of double occur is, you can have 2 1s, 2 2s, 2 3s, 2 4s, or 2 5s, right? So 6 sample points in this event. The total number of sample points in the sample space is 36. So the probability is 1/6. That means in each row, the probability of double occurring is 1/6, right? And here, what is a random variable? We use uppercase X to denote the random variable. Okay, let X denote the number of times that double occurred in the 5 rows. Then X is a binomial distribution, right? Because in each row there are only 2 outcomes, whether we roll a double, right? And the probability of rolling a double remains constant, which is 1/6. So here, X, if we use X to denote the number of times that double occur in the 5 rows, then X yields to a binomial distribution. Okay. The first parameter is 5 rows. That means 5 trials. Second parameter is 1/6, which is the probability of double occurs, right? So it asks you to calculate X being 2 here. Okay, according to binomial formula, X being 2, the probability of X being 2 is C5(2). 1/6 twice. 1/5 3 times, right? So it's 10 times 1/36 times he is 0.1608. Okay, any questions? No? All right, let's see the next one. A card is repeatedly cut from a deck and replaced each time. What is the probability that in 10 trials, an ace is cut A once, B 3 times? Okay, assuming here a standard deck of cards has 52 cards. Okay, all right, I'll give you 10 minutes to think about this question, and then we'll discuss it together.
Hi, Mr. Wang, can you go back to the last slide? Thank you.
Any questions?
Okay, thank you.
All right. All right, have you finished? Okay, here you have 10 tries, right? And in each trial, the probability of cutting an ace is always the same, right? So first of all, we calculate in each trial, the probability of cutting an ace. First of all, we calculate the probability of cutting an ace. There are 4 aces in the standard deck of cards, right? And 52 cards in total. So the probability of cutting an ace is 1/16. And each trial is independent to each other. And this probability remains constant. So that means this is a binomial experiment, right? And what is a random variable here? Again, we use an uppercase X to denote the random variable here. Okay. That X denotes the number of aces we cut in the 10 tries, right? In 10 tries, the number of cases we cut is a random variable. It could be 0 or it could be 10, right? And could be any number between 0 and 10. So let X denote the number of aces we cut in the 10 tries. Then, according to our analysis, X yields to a binomial distribution. First parameter is number of tries, that means 10. The second parameter is the probability of an ace is cut, which is 1/16, right? So here, A, it asks you to find the probability of X being 1, which is C10(1) times 1/16 to 1 times 12/16 to 9 times, right? Okay, let's calculate this using a calculator. This probability is 0.3742. Okay. Second question asks you to calculate the probability of X being 3, which is according to the binomial formula, C10(3) times 1/16 to 3 times 12/13 to 7 times, okay, which is 0.03119. Okay, any questions? Okay, please have a look at this. Do you have any questions? All right, if you do not have any questions, let's see the next question. The failure rate is 5% in the initial production run of a new computer chip. A quality control inspector selects 30 chips for testing. A, what is the probability that more than 2 of them are defective? B, what is the expected number of defective chips? Okay, I'll leave you 5 minutes to solve it. All right, let's see what we can do. How we can do this. Okay, what is a random variable? When you have a question like this, the first question you should ask is, what is a random variable here? Actually, the quality control inspector selects 30 chips for the testing, right? So within the 30 chips, the number of defective chips is a random variable, right? It could be either 0 or 30 or any number between 0 and 30, right? So here, first thing you need to make clear is what the random variable here. All right, so usually we use uppercase X denote the random variable. So here let X denote the number of defective or perfect, right? Whether it's defective or perfect, it depends on what the question asks you to do. In the question, it asks you to calculate the probability of more than 2 of them are defective. So here we use defective number of chips. So let X denote the number of defective chips in the selected 30. Okay, here we select 30 chips, right? That means we conducted 30 experiments. In each experiment, the probability of having a defective chip is always constant, which is 5%, right? So according to this analysis, the random variable X here yields to a binomial distribution. First parameter is the number of total experiment, which is 30. The second parameter is the probability of this event happens in each trial, which is 5%, right? Okay, so question A, what is the probability that more than 2 of them are defective? That means we are going to calculate the probability of X equal to or over 2. Oh, sorry, not equal to. It says more than, right? More than means X more than 2. Okay. So probability of X more than 2 means X could be 3, 4, 5, 6, 7, 8 until 30, right? If we calculate straightforward, there are a lot of calculations, right? So usually we can calculate the probability of the opposite, which is X equal to or less than 2, and use the total probability 1 or 100% minus this probability. So in this way, we only need to calculate the probability of X being 2 and the probability of X being 1 and the probability of X being 0, right? Okay, so here we are going to calculate the probability of X being 2 according to the binomial formula, which is C32, 0.05 to twice, 0.95 to 28. Okay, the second one is C31, 0.05 to once, 0.95 to 29, and C30, 0.05 to 0, and 0.95 to 30, right? Okay. And we need to calculate these three probabilities using a calculator. Okay, the first probability is 0.2586. Okay, second one is 0.3389. Okay, the third one okay, 0.2146. Okay, so that means the probability we are looking for is 0.1879, right? Okay, the second question. What is the expected number of defective chips? Okay, so when you select 30 chips, sometimes you have more defective chips, sometimes you have less defective chips, right? So the expected number of defective chips means on average, each time you selected 30 chips from the production line, the average number of defect chips is what, right? Because X here is binomial distribution. So if we want to calculate the expected number of X, we can use the shortcut. EX is NP, right? Because X is a binomial distribution. So EX is NP, which is 30 times 0.05, which is 1.5, right? That means for each 30 chips you selected, on average, you will get 1.5 defective chips. Okay. Any questions? No? All right. If you have no questions, let's see the next one. Okay, which expression best represents the probability of 3 successes in 7 independent trials in the binomial distribution? Okay, this is a simple one. I'll give you 1 minute to solve it. All right, what is the correct option here? So basically here you want to calculate, suppose we have a random variable that yields to a binomial distribution. Here it asks you to calculate the probability of 3 successes, right? In 7 independent trials, that means n is 7. So here, according to binomial formula, we have C7, 3, P3, Q4, right? Q here is 1 minus P. So the correct option is A. Okay, any questions? All right. Next one. What is the expectation for a binomial distribution with P is 0.5 and N is 8? Okay, we have already discussed this, right? If X yields to a binomial distribution, then the expected value of X is NP, right? So we can directly use this formula to calculate the expected values. So here N is 8, P is 0.5. So the product would be 4. So here B is the correct option. Okay, any questions? No? All right, let's see the next one. 6 people are asked to choose a number between 1 and 20. What is the probability that A, 2 people choose the number 9, B, at least 2 people choose the number 9? Okay, I'll give you 5 minutes to solve it, and then we can discuss this together. All right. Any ideas? Okay, again, when you are faced with such a question, the first question you need to ask, what is a random variable here, right? What is the random variable here? That means you need to find the meaning of the RV. Okay, so here we have 6 people, right? That means we conducted 6 trials, and in each trial, the person can choose number 9, or the person choose some number else, right? So there are only 2 outcomes, whether this person choose number 9. And the probability of choosing number 9 is always constant, right? Which is 1/20. Okay. I'll make a note here. For each person, the probability of choosing number 9 is always 1/20, right? Because we have 20 numbers in total. So the probability of choosing number 9 is 1/20. Okay, and then we use uppercase X denote the random variable. So here, let X denote the number of people that choose 9 in the 6 people. Okay, then according to our analysis, here X yields to a binomial experiment. Yields to a binomial distribution. The first parameter is n, which is 6, right? Because we have 6 people here, means we conducted 6 experiments. The second parameter is the probability of each person choosing number 9, which is 1/20. So question A actually asks you to calculate X being 2, right? The probability of 2 people choosing number 9, which is according to binomial formula C62 times 1/20 twice times 19/20 4 times, right? Okay, which is, you need to use a calculator to calculate this. Okay, so the result is 0.0305, right? Okay, so second question, at least 2 people choose number 9, means the probability of at least, it means X equals to 2 or X/2, right? So again, here it is simpler to calculate the opposite probability, which is 1 minus Px less than 2, right? P less than 2 equals to Px being 1 and X being 0, right? So here we only need to calculate two probabilities. Probability of x being 1 is C61, 1 over 20 to 1. Okay, times 19 over 20 to 5 times. And the probability of being 0 is C60 times 1 over 20 to 0 times 19 over 20 to 6 times. Okay, which is 1 minus 0.2321 plus 0.7351. Okay, and the final result is 0.0328. Right, any questions? Any questions? Okay, let's see the next one then. Two dice are rolled repeatedly and their sum is recorded. A. Show the probability distributions for the number of sums of 7 in 5 rows. B. Graph this distribution with a probability histogram. Okay, this time it asks you to calculate the whole probability distribution, right? So that means you have to show the table that the random variable can, the values that the random variable can be, and all the corresponding probabilities. Okay, I'll give you 5 minutes to solve it. All right, any thoughts? Okay. Again, first question you should ask here, what is a random variable, right? The random variable is in 5 rows, number of times you get a sum of 7, right? So here we denote, use uppercase x denote our random variable. Let x denote the number of times sums of 7 occurs in 5 rows. Because each row is independent and the sum of 7, the probability of sum of 7 is constant, right? So here the x is actually equal to a binomial distribution. Okay, the first parameter is apparently 5 because we have 5 rows. The second parameter, we need to calculate this, right? Second parameter is the probability of the sums of 7 occurs. Okay, for each row, how do we get the sums of 7? We can have 1, 6, right? Because there are 2 dice. Or we can have 2, 5 to have sum of 7. Or 3, 4. Or 4, 3. Or 5, 2. Or 6, 1, right? We have 1, 2, 3, 4, 5, 6 sample points in this event. So the probability of sums of 7 is 6 over 36, right? Because 2 dice, there are 36 sample points in the sample space, which is 1 over 6. So the second parameter here is actually 1 over 6. Okay, 1 over 6. And if we want to calculate the probability distribution of x, we need to calculate each probability of x being 0, 1, 2, 3, 4, 5, right? Okay, that means we need to calculate 6 probabilities. Okay, the first one is x being 0, which is C5, 0. 1 over 6 to 0. 5 over 6 to 5, which is 0.4019. Okay. The second probability of x being 1 is C5, 1 times 1 over 6 to 1s times 5 over 6 to 4s, right? Which is approximately 0.4019 again, right? Okay. Probability of x being 2 is C52 times 1/6 twice times 5/6 3 times, which is 0.1608. Okay. Next one, probability of x being 3 is C53 times 1/6 3 times times 5/6 3 times. Sorry, there should be 2, right? Should be twice here. Should be twice here. Okay, this probability is 0.0322. Okay, next, the probability of being a 4 is C54 1/6 4 times 5/6 1 time. Which is 0.0032. Okay. Last, the probability of x being 5 is C55 1/6 5 times 5/6 0 times, which is approximately 0.000129. All right, then the probability distribution of x is actually a table, right? Okay, x is here. So the values that x can be is 0, 1, 2, 3, 4, 5, right? And the corresponding probabilities are, okay, simply put these probability numbers here. Okay. And it's better for you to validate the sum of all the probabilities in the second row should be equal to 1, right? If it doesn't, that means probably the calculation is incorrect. Okay. B, graph the distribution with a probability histogram. That means you could use a bar chart to illustrate this probability distribution. Okay, suppose we have a bar chart here. That's our random variable. And here is our probability distribution, probability, right? Okay, here's x. Okay, first we have 0. Okay, when x is 0, the probability is 0.4019. Okay, when x is 1, the probability is also 0.419. Okay, when x is 2, the probability reduced to nearly half, right? Which is 0.1608. Okay, when 0 is 3, probability is much smaller. Okay, when x is 4, even more smaller. Okay, when x is 5, it's probably the smallest, right? Which is 0.000129. Okay. Okay, any questions? Okay, pay attention here. If this question asks you to calculate the probability distribution, you need to calculate all the possibilities, all the probabilities. Okay. All right, let's see the next one. In archery competition, Paul hits the bullseye 45% of the time. A. Show the probability distribution for the number of bullseyes in 8 attempts. B. What is the expected number of bullseyes in 8 attempts? Okay, I'll give you 2 minutes to finish it. Okay, let's see how we can solve this. Again, the first thing is to find what is a random variable here, right? Okay, here we use uppercase X to denote our random variable. The random variable should be the number of bullseyes in 8 attempts, right? So we can write let X denote the number of bullseye in the 8 attempts. Then we know that x yields to a binomial random variable, right? Because all the 8 attempts are independent, and the probability of being a bullseye is constant. Okay, here we have 8 trials, and in each trial, the bullseye, the probability of being a bullseye is always 0.45, right? In the previous question, we used a table to represent the probability distribution, right? And actually, we can also use a binomial formula to represent the probability distribution for a binomial random variable. Okay, so according to the binomial formula, the probability distribution of x is actually, okay, for any k that lies on this interval, the probability is C8k, 0.45 to k times, and 0.55 to 8 minus k times for all k that lies in 0 to 8, right? For other values of k, otherwise, this probability is 0, right? Because x cannot be the value outside this interval. So this is the probability distribution of x. Okay, question B. The expected number of bullseye, that means EX, right? Because x is a binomial random variable, so EX is NP, which is 8 times 0.45, which is 3.6. Right? Any questions? No? All right, let's see the next one. A machine makes light bulbs and 6% do not meet the specifications. An inspector randomly chooses 10 light bulbs for testing. What is the probability that between 3 and 7 bulbs do not meet specifications? Again, this question asks you to calculate a probability that x falls within a specific interval, right? Okay, so first of all, what is the random variable here? Let x denote the number of bulbs that do not meet specifications in the chosen 10. Then your x here is a random variable, right? And also we know x yields to a binomial distribution. The first parameter is 10 because we have conducted 10 trials. And in each trial, the probability of being not meeting the specification is 0.06. So here it asks you to find the probability of x between 3 and 7, right? That means we need to calculate 5 probabilities, okay, which is x being 3 plus x being 4 plus x being 5 plus x being 6 plus x being 7. Okay, due to time constraint, I will not calculate this. Please do calculate this after the class by yourself. All right. Okay. Any questions?
老师，我能不能看一下上道题？我刚刚没抄完，过程有一点点。行，谢谢老师。我开了，没问题了，我截图了。
Okay. Okay, I'll write one step after this. Okay. All right, any questions? Okay, let's see the next one. Jamal is successful on basketball free throws 80% of the time. How likely is he or to be successful on at least 8 of 10 free throw attempts? Okay, I'll give you 1 minute to think about this question. All right, so it's very similar to the previous questions, right? So first of all, we need to be clear what is the random variable here. Let x denote the number of successful attempts in the 10 attempts, right? Then x here yields to a binomial random distribution. The first parameter is 10 because there are 10 experiments, right? The second is the probability of each time being successful. That means 0.8, right? Because probability here is 80. Then it actually asks you to calculate the probability of x at least 8. That means equals to or over 8. Okay, so here we have to calculate x being 8 and x being 9 and x being 10, right? Which is C10 8, 0.8, 8 times, 0.2, 2 times, plus C10 9, 0.8, 9 times, 0.2 once, plus C10 10, 0.8, 10 times, 0.2 0 times. right? And again, I will not calculate this here. Please calculate them by yourself after the class. All right? Any questions? No? All right, let's see the last question. Jean forgot to study for an 8-question multiple choice quiz. Each question contains 4 possible answers. Jean will guess the answer to each question. What is the probability that she will get only 2 questions correct? What is the expected number of correct answers on the quiz? Okay, I'll give you 2 minutes. Okay, let's see how we can do this. Okay, like your role, we have to find out what the random variable is here, right? Okay, let x denote. Say, okay, what's the random variable here? There are 8 questions, right? Okay, after 8 questions, the number of correct guess is a random variable, right? She could have 0 correct ones or 8 correct ones or any number between 0 and 8, right? So let x denote the number of correct guesses in the eight guesses, right? So that here x is a random variable that yields to a binomial distribution. The first parameter is 8 because we have 8 trials here. The second parameter is the probability of guessing correct in each quiz. That means 1/4, right? Because for each question, there are 4 possible answers. That means 1 correct answer out of 4 possible answers. So the probability of guessing correct for each question is 1/4. Okay, so here it asks us to first one is to ask us to calculate the probability of x being 2, right? Only 2 questions correct. Okay, so this one is C82. 1/4, 2 twice, and 3/4, 2, 6. Okay, which is approximately 0.3115. Okay, question B. What is the expected number of correct answers on the quiz? So that means sometimes you can guess, you can have a lot of correct guesses. Sometimes you have fewer correct guesses, right? And on average, what is the number of correct answers? That means you have to calculate the expectation of x, right? If x is a binomial distribution, the expected value of x is np, right? So n here is 8, p is 1/4. So the expected number of correct guesses is 2. Okay. Any questions? No? All right. If you have no questions, we do not have any homework. The only homework is to review today's lesson and the lecture slides of what we have learned so far in Unit 2.